Welcome to Graphing Rational Functions. Before I begin, I do want you to go back to page 4 and look at all those basic graphs again because you will need to recognize them in order to draw the graphs that we're going to do in this lesson. So go ahead and take a look, refer back to page 4 and look at the different names of those graphs, like the two-piece graph, the anthill, the three-piece graph, the hole in the graph, the volcano, and so on. Okay, so for our first example, this format looks like the two-piece graph because we have 1 over a x. So this is a two-piece graph. The only difference between this graph and the other one on page 4 is that there's a negative in the front. And what that is going to do is change those arms in different quadrants. So in y equals 1 over x, we have it in quadrants 1 and 3. And we're going to see what quadrants our negative 1 over x is going to be in just a moment. Let's take a look at our asymptotes. If x was 0, we're going to have a problem because our denominator cannot be 0. So that means we're going to have a vertical asymptote, a VA, at x equals 0. And you can draw it in. I know it might be a little hard to draw it in when you already have a black line and you're trying to draw it with a pencil, but do your best to show that there is an asymptote there. We are also going to have a horizontal asymptote at y equals 0. Okay, so whenever you have your numerator power is smaller than your denominator power, your horizontal asymptote is going to be y equals 0. We know the general shape of this graph. We have 2 arms, and those arms go in specific quadrants. I'm just going to do a small table values on the side to figure out what exact points there are going to be. So let's just say that if I had a negative 1, that's going to be negative 1 over negative 1, which is positive 1. And then I'll choose 1 for my other x value, which is going to be negative 1. So those are our points. We have negative 1, 1. The other one's at 1, negative 1. Because our points are here, we know that that's where our arms are going to go. So if you look back at your y equals 1 over x graph, it kind of looks like this. So that just means that our points change into different quadrants. We're going to do the same shape in that quadrant. Be careful in how you draw your arms. On the provincial exam, they are very particular about that. So make sure your arms look like they're approaching your asymptotes, but they're not touching them. Okay, so that is y equals negative 1 over x. This next graph, if you take a look at all your other graphs on page 4, it's most similar to your two-piece graph. The only difference is that we moved our horizontal asymptote and our vertical asymptote. So in this case, our VA, well, we're going to have a problem in our denominator if x is equal to negative 2. So that is where our VA is, x equals negative 2. This 4 tells us that we moved up the graph by 4. So that is where our HA is. So it used to be at y equals 0, but we went up 4, so now it's at y equals 4. This is in descriptive form, which is what we covered last lesson. And this is easier for us to graph because it tells us what our VA is and our HA is. So I'm going to go ahead and draw in the VA and HA. Okay, so that's what we have so far. The next thing I need to do is find out, well, what quadrants and what are those points going to be? Because it's positive, our sign in front of our rational is positive, that means we're going to have it in the usual quadrant 1 and 3, or in this case, it'll be in here and here. But we do need the specific points. So on the provincial exam, you do need to find 2 points for that graph. So we can use that we can use the table values to find those. I'm just going to do 1 on each side of my vertical asymptote. So I'm going to look at x equals -1 and also x equals -3. Okay, so if I plug in -1, I'm going to get -1 plus 2 in the denominator, which is 1 plus 4, and that's 5. Then for -3, I'm going to get 1 over -1 plus 4, which is 3. So those are our points. We have it at -1, 5, and the other one's at -3, 3. Then we're going to follow the same shape for our two-piece graph. Our arms are approaching the asymptotes, but not touching them. Extend a bit with those arrows, and then we are done. Here's our next graph. So this one, we want to be careful. We have something squared in the denominator, and it's x plus 2. So here we will have a vertical asymptote at x equals -2, because if I have -2 plus 2, I'll get 0 in the denominator. And the graph that has a vertical asymptote with a squared in the denominator is your volcano graph. And because we don't have a plus something here or minus something, our HA is just going to be y equals 0. So we can go ahead and draw those in. Now our next step is to find 2 points. So I'm going to use the x values on either side of my vertical asymptote, which can be -3 and -1. So if I put -3 in there, I'm going to get 1. And if I put -1 in there, I'm also going to get 1. Okay, so we're going to plot those points that we just found from our table of values, and then follow the same shape for all volcano graphs, which means I'm going to approach the asymptotes, but not touch them, just like so. For our next graph, this one looks like our anthill. Why? Because we have x squared plus a number. And nothing can be defined here, because in order for this to be defined, I would need to find some real number of x such that x squared plus 4 would be 0. And if you try to solve for that, nothing would exist that's real, like a real number. Okay, so that just means I'm going to find 2 points so I can draw my anthill. So we can pick 0, we can also pick 1. So if we plugged in 0, we're going to get 1 over 4. And if we plugged in 1, we're going to get 1 over 5. You still have a horizontal asymptote though at y equals 0. And then we have a point at 0, 1 over 4, and then another point at 1, 1 over 5. Then we're going to draw the same shape as what you see on page 4. That looks something like this, where you're approaching your asymptote. So here we have no VA, but our HA is y equals 0. Okay, then for E, we do need to factor their denominator first, which is x plus 2, x minus 2. And that means we're going to get a vertical asymptote at x equals -2 and +2. And our HA is going to just be y equals 0. Okay, so I'm going to go ahead and draw those asymptotes in. Then our next step is to find not 2 points, but 3 points. Because we have 3 sections, we need a point from each section. I'm just going to pick an X on the very right side of our first vertical asymptote, so that can just be 3. And I'll pick the one in the middle of the 2 asymptotes, which can be 0. And then lastly, I can just pick -3 for our very left side of the graph. Now I'm going to find the corresponding y values. That's going to be 1 over 3 plus 2, 3 minus 2, which is 1 over 5. For 0, we're going to have -1 over 4. We have -3. We're going to have 1 over 5. Okay, so I'm going to plot these points. And what I can do, instead of labeling my y-axes, I can just draw the point in and then label it right there. So I can just say this is 3, 1 over 5. And that's easier to do when we have fractions in our y value. Then I'm going to plot the next one, which is 0, -1 over 4. And then lastly, -3, 1 over 5. Then I'm going to follow the same shape as what we kind of see in our 3-piece graph on page 4. I know that this section here, I'm going to have arms that tend towards our asymptotes. Then I'm going to have an upside down parabola. Then our very left section, again, I'll have arms approaching the asymptotes. And that'll be our final graph. Before I can say we're done, I'm going to find the domain for each of these. So that was actually in the original question. It says provide the domain. So going back to example 1, you always look at your vertical asymptote to see what your domain could be. So you can state your domain as -infinity to 0 and 0 to infinity. Or you can say it in set notation that x is the element of the reals such that x can't be 0. For B, our VA is at -2, so our domain then would be -infinity to -2 and -2 to infinity. Or you can say x is the element of the reals such that x can't be -2. Your volcano graph is going to have the very same domain because our VA is at -2. For your anthill, this is going to be from -infinity to +infinity, or you can say x is the element of the reals. We don't have any holes or any asymptotes, so this graph can be any x value. Then lastly for E, we have 2 asymptotes in this case, so we have to consider the time when we cannot be at -2 and +2. So that's -infinity to -2 and -2 to 2 and to infinity. This shows that we have 3 sections of the graph, and which we do. Or you could say that x is the element of the reals such that x can't be -2 or 2.